Thank you for that introduction, Brent. It's the end of the second day. I know that you're all really tired, but I'm going to be throwing things around the screen, so hopefully that kind of wakes you up. Are you ready to learn about complex, beautiful animations in the DOM on the web? Yeah? My name is Sarah Drasner. I'm Sarah Edo on Twitter. This is a photo of me as a child and my relationship with authority. I'm a consultant, which does not mean that I'm unemployed. I work for a bunch of different companies. Some of them are listed here. And I'm actually fortunate enough to work on a lot of cool projects. I'm going to highlight some of the work that I'm doing with a company called Workflow today because some of the stuff that we're making is really, really cool for React development. It has not been released yet, so look forward to that in the future. It's also worth mentioning that in this talk, I'm going to start with some theory and then get progressively into more technical details about implementation. So if you need to take a nap at any point, you know where to take a nap at. So I'm not going to go into too much detail here, but before we dive into animating the virtual DOM, it's really important to address what's changing about the way that we're rendering the virtual DOM in the future with React Fiber. Fiber is a major change to the way that the reconciler schedules updates to the renderer. There used to be no preference given to different kinds of updates, so when data was scheduled over things like animation, it would cause pauses in the interpolation of states, which made for a kind of janky visual representation. In Fiber, animation gets prioritized over less important things now. It's scheduled with request animation frame, thus becoming a first-class citizen. Now, many of you may be thinking, but animation's fluff, why should we care about it so much? The thing about it is that if we improve rendering for animation, it improves rendering for every visual expression of state change. Anytime you're interpolating state, you're exposing all of the leaks and intricacies of those DOM diffs. The updates to Fiber help not just animation, but rendering all around by being a bit smarter about the scheduling of those updates. So now the examples that I'm showing today are not taking full advantage of Fiber yet. I'll be diving into what you can use now. We've evolved to perform actions that flow more or less seamlessly. We aren't wired to deal with the fits and starts of human-computer interaction. This is a big deal because our memory store in our occipital lobe works fundamentally in 100 millisecond bursts. As humans, we're accustomed to flow-based action, not togglings of states. And by shifting these actions too quickly, we lose a certain amount of context. So here's what's particularly exciting. We all know that React excels at encapsulating any state that's changing. And the whole purpose of animation is tying two states together with interpolation. So by not just toggling those states and instead exposing the moments in between, we build a story that is actually less cognitively tasking for our users. It's as if we're telling a story. And in storytelling and in building websites, we have something called the so what factor. People start off intrigued, but their attention span starts to drop off around 2 seconds. So Amazon's discovered that after every 1 second delay, conversions drop by 7%. Walmart found that it gains 1% revenue increase for every 100 milliseconds of improvement. So how do we make sure that we're finding the most clear and useful path in our app from one piece to another? If you spend a moment aligning yourselves with what the end goal is, it all of a sudden offers clarity for what might happen in between. This also helps track what validation looks like. React brought all of front-end development together into a new age by understanding how to responsibly manage state. This is great because now we have a record for what's changing. As a user and a human, you're constantly tracking the space around you. You're creating spatial awareness. This is eye tracking movements on a heat map of one single page. We move our eyes constantly in an event called saccade to understand where everything lives. That also means that anything that changes forces us to remap that space and creates a cognitive load. If the entire team is aligned from beginning to end, you can start to connect these states in a way that reduces friction for the user. So if we're talking about ways to keep that experience from feeling so jarring, we have to discuss animations and transitions. Without transitions, we lose an opportunity. The user has to remap every interactive space, like we mentioned before, and it doesn't feel as fluid. Here's a great example from Code Drops, where just choosing your seats at a movie theater, you get a real understanding of spatial awareness as a user, and it's much more helpful trying to navigate or make a decision. I'm biased, of course, because I've been working on this project, but part of the reason why I cleared my schedule for Workflow as a client is because I think this project is so cool for React development. Workflow is a place to manage all of your React components. It's a living style guide that gives you a productive environment for building components and getting on the same page with other engineers, designers, and PMs. We've been talking about connecting states for the user, and this is shown through our walkthrough flow. It uses animation to illuminate how to work through the UI and connect these states. So you're taking through a few interactions which highlight what you should be paying attention to. The dialogue speaks to you like you're a human and establishes a relationship so that you feel at home. And that last confirmation screen has a burst to let you know that you're successfully set up. So when we talk about connecting these states, we have to actually make our app feel faster and easier through perceived performance. A couple people have mentioned this before. So here's one thing that people haven't mentioned before. Humans actually overestimate passive wait times by 36%. So even if you're using Lighthouse or if you're using Chrome DevTools and Timeline to record things, it's not telling you the full story because that actually, the way that it feels can change. Vigit did a study where they did like a kind of custom GIF loader and an old-timey GIF loader, and they did a custom loader which was just some dots on the screen. People were willing to wait twice as long for that custom animation, even though it wasn't flamboyant or that interesting. We also know that through MRI scans that if humans have to wait more than 4 seconds for a UI to load, they have the same feeling that they do when they're watching a horror film. So uncertain wait times are longer than known or finite waits. And Disney World and airports understand that you need entertainment while you're loading, so Disney World will show you like little animatronic things while you're waiting. Airports make you walk a really long way to get your bags so that you show up and your bags are there. You're like, I didn't wait that long, even though it's the same amount of time. People also want to get started, so that's why the doctor brings you into the exam room before they're ready to see you. Then you feel like you're already on the doctor journey and you're not sitting in the wait room. So I made this loader for Smashing Magazine for their checkout experience. The loader itself is not the important part. The important part is that the entire file size of this is 6 kilobytes because I'm using SVG for the graphic and I've optimized correctly. And I'm keeping everything terse and small. I think SVG is incredibly powerful for DOM-based movement, and so we're going to talk about that a bit today. One of the nice things about SVG as a format is it's so flexible. It's built with math, so we can manipulate it and make it bounce and snap. This is in honor of the Yarn release. So a lot of people, when I work as a consultant, think like, oh, but SVG is not well supported. It used to not be well supported. It is supported now. Look at all that green. We even have Opera Mini. We never get Opera Mini. And it says 11 there, but this actually goes back to IE 9. So I'm going to take a super brief detour here to clarify what the scalable means when we talk about scalable vector graphics. You see here when we place the graphic directly in line in the HTML, it has width and height attributes and that keep it to that size. But if I take those out, you can see the graphic take up all available area. And then with styles, I can constrain the viewport width and height. I can make it fill up the space of a CSS grid or a flex box or anything goes here. And the graphic and its innards stay totally consistent. So if you don't like positioning with styles, SVG is incredible because you can see how stable that graphic is, even though there are multiple elements inside it that you can now access through that navigable DOM. So I could even be putting text in there as well. So, okay, we've talked about why it's effective to animate in React, and we talked about SVG a little bit. Now let's get into the nitty-gritty of some things available to you with actual code. When we're working with animation, we can start to think about certain aspects of the way that we're building our components as the pieces that we'd like to iterate on. In this case, with the sound visualization, I might want to alter things like the timing of the entrance and the timing of the exit. So we'll go into more detail about how we built the animation for this component a bit later, but an important piece of this choreography is thinking about things like timing and eases in animation pieces that we can easily change in conjunction with an entrance or exit. Timing is incredibly important. It's good for jokes, it's good for introductions. This is a really bad dark UX pattern that you're probably familiar with when you visit Groupon for the first time. This modal comes up. I'm not even sure I want to use it or if I'm going to find that site useful and it's already asking me for my information. It's like, come on, buy me a drink first, you know? If you think I'm being picky, know that Google agrees and will now drop your SEO if you have a timed interstitial on mobile. So this is documentary footage of me trying to use that site or a lot of other sites on my phone. The funny part is we're already used to thinking about building apps this way with text and layout, but a lot of times we add animation in an ad hoc manner that makes it feel inconsistent. So one way that we can easily fix this is to create beautiful defaults. And why should we do that? It seems like a lot of work, huh? Like, who cares? Well, it's the same thing as any other technical debt. If you do a little bit of work up front, it's easier to build and iterate in a cohesive manner after that point. We can create these defaults for easing for things like entrance, exit, entrance emphasis, and give all of your animations a similar feeling across your whole site, no matter the timing. And you never have to remember it again, right? I never have to copy paste a cubic Bezier ever again. I keep plugging into that entrance. This helps my teams move really quickly, even if the other engineers aren't into animation. They already know that they're going to use an entrance for an entrance and an exit for an exit. We use things like H1, H2, H3 for body copy, and we know that H5 is the default. That's what our body is all going to be like if we don't set anything else. We can do that with timing as well. So we can create timing units of T1, T2, T3, and understand that T5 is the default, the typical timing. So now we've already created a situation where nobody has to think about eases and nobody has to think about timing. They can just think about where the thing is coming from and where the thing is going to. And then we can iterate on them, right? So in creating these beautiful defaults, we can have us not just reinvent the animation wheel every time we try to make something. We have way less to think about. We decide what kind of animation we're using, and we can easily adjust timing if we need to. So if we think a little bit more about a common UI example here, let's say we're building out a card. We can create composite components where we're putting these pieces together and even adding a specific animation component that handles the entrance and exit. So I love how quickly I can build that out now. I'll show you how I created this entrance and exit coordinating ReactTransitionGroup Plus and GreenSock a little further into this talk. Okay, so animation landscape is actually pretty big, even though it's just one piece of React, and we don't have that much time today. So we're going to spend time near the DOM side of things, even though it's way bigger and there's way more there. We're not going to talk about native and Ken Wheeler and guns and beer stank and canvas and all of that. We're going to stay over that in that direction. Okay, so the first library we're going to look at is Mod.js. One thing I like about it is you don't even have to open a graphics editor. It has built-ins like bursts and swirls. You can begin to use them with just one line of code, as you see here. And it comes with a ton of SVG shapes, so you can just access these and apply them to children of burst or swirl animations. And on my personal site, I use a slew of these shapes as children of the burst, and within a couple of minutes, I'm able to spin up some pretty fun feedback on my form submission, on my button for my submission form. I decided to create something that's open source so you can dig into how you'd use Mod.js with React, so of course I chose to make the thing that's most useful to you a bursting hot dog. Probably the most important piece of that whole demo, though, that I'd like to call out to you is that you should be returning false on should component update. That will get you the best performance. A few years ago at this very event, Cheng Lu open sourced React Motion. React Motion is a really beautiful library that offers interruptible single movements. Unlike the timing changes we worked with earlier, React Motion doesn't really work with the concept of time. Instead, it's similar to game-based animation, where you give something mass and physics and send it on its way. Here we're working with staggered motion that's unique as well. Instead of simply staggering the timing, we're actually updating each subsequent element from the last one's placement. So in essence, it's getting that motion for free, and we can create these really beautiful interactive effects. Of course, we don't need to make these huge movements either, right? That's not the most common use case. So in this example, I have a layout with small staggering animations when we change out those circles, as well as some hover events for the text elements. So you can also see how we're using SVG here, and it's really easy to make it scale for responsive in an interesting manner without too much positioning craziness. In those circles, we're updating with a click, and we're using a staggered motion component to use the previous styles to then update the next one's placement. And in the component itself, we can pass an array of path values, give each path a key, and update the opacity. Here's another example of how React Motion at work. Here we're updating many parts of the SVG, some with rotation, and some are drawing letters onto the page. Now, drawing SVG is not something particular to React Motion, so let me teach you how to make that work, and you can use it in something like React Move or any of the other options too. Okay, imagine that you have a path or a shape, and that whole shape has a stroke. That stroke is dashed. We have a native method in JavaScript that is called getTotalLength, so I can get the total length of that shape, and then I can make that dash the whole length of the entire shape. And that dash offset is animatable. So now I can animate that dash offset and have SVGs look like they're drawing themselves onto the screen. So I've already logged the length of all the letters, and the 200 is the maximum value. So I can use a ternary to toggle and therefore draw the length of the whole dash onto the page. And that's how I created the animation for Trulia's responsive navigation. We have React Motion updating the stroke with the nav icon on hover, and then on click, we transform the other pieces to make an X and to open the nav. So you can see how fluid that motion is. It feels really nice. So there's a lot of tools to cover. We're going to go quickly through a whole bunch of them right now, so just so that I can give you a purview of the landscape. I work with all of these tools, so I thought I'd break down my recommendations for each of you. All of these tools work well. They're just good for different types of use cases. CSS and JS or styles or something like that are great for small sequences and simple interactions. They're awesome because you don't have to load any additional resources, but CSS is not very powerful. We're updating in two places because we've got our keyframes and then we have to apply them, so that's not great. We also have to chain them by writing subsequently longer delays each time. So if one of them changes, you have to go back and change all of the delays that follow. So that's not so great. That's not such a great workflow, especially for complex animation. I'll go into depth about this in a moment, but GreenSock is a really, really great for sequencing complex movement. It's also really good for cross-browser stability, so it's great for high-quality production sites. React Motion, as you saw, is awesome for basic movements you'd like to make realistic, but it wasn't really designed for sequencing. So you can't really write a loop without writing an infinite loop. Don't do that. So there's a kind of a limit to the kind of interaction that I would use it for. React Tween is similar to React Motion, but it does use the concept of time. So due to the fact that we're wrapping each element in a motion component, it can get very verbose if you're trying to sequence a bunch of elements and events together at the same time. React Move is similar to React Motion, and it also doesn't have a concept of sequencing, but the major advantage of React Move, though, is that you can schedule with time or with springs. It's very, very flexible. People always ask me if I use Snap SVG because I animate SVG. Snap is not actually an animation library. It's meant for DOM interactions like jQuery. So if you ask the author, Dmitry Baranovsky, what he recommends, he'll tell you that you should be using GreenSock. And even if you go to the demos on that page on their site, they're all done with CSS animation. Web Animations API looks fantastic because it will be native to the browser. You won't have to add any external libraries. It will be good at sequencing, but it's not yet well supported, and even if you use a polyfill, it sometimes breaks as things change because they're still updating the spec. So don't put that in production sites unless you like PagerDuty on a Saturday. This will be a really, really good tool when it comes out. Velocity React is similar to GreenSock, but has slightly less bells and whistles and less offerings. So I also ran some performance tests on it, and it didn't fare so well, but those were run a long time ago, so they might not be viable anymore, and you should really be testing things for yourself. Mod.js, as you saw, is beautiful for spinning up shapes and creating really, really beautiful types of motion. It does have things like timeline, and so you can sequence animation and use a curve editor for eases. There's all sorts of really cool tools kind of built into it that I don't have time to cover today, but it's still in beta. So I would keep an eye on this one. It's pretty close to being released now. So one library that comes up again and again when I talk about creating beautiful movement with React is GreenSock. It's been under development for 10 years, so it has a ton of offerings, including docs and forums. The thing that sticks with me is that it's very tough to find something another tool can do that GSAP can't do, but there's plenty of things that GSAP can do that other tools can't, and I'm going to show you some of those things today. So some of the things that we're going to cover are transforms, cross-browser inconsistencies, morphing, and sequencing and chaining. So let's talk about transforms first. Most of you probably already know this, but in case you don't, in terms of animation on the web, not all properties are created equal. Opacity and transforms cause the least amount of repaints, and they're the most performant. So transforms offer a ton of ways for you to manipulate elements too, like skews and scales, so that if you feel bad because it's only one property, there's actually a ton in that one property. There's also a few ways to hardware accelerate an element with styles, shown here. So in here, I've made one animation with margin left and one with transforms. And you can see the top one, that's margin left, is kind of jittering around. And then if I illuminate in the browser with Chrome DevTools, the paint flashing, you can see that green box is actually illuminating what's not being properly hardware accelerated and what's causing a lot of repaints. So the transforms are doing better than the one on the top, which is margins. But transforms have a trick, of course. Stacking, the problem with transforms is that they stack. So if I was going to apply a bunch of different transforms at a bunch of different times in a keyframe animation, what would end up happening, so if I want that thing on the right to happen here. So if I want that to happen, what will actually happen is the thing on the left. They'll start to stack and create an order, which is not ideal and can cause a lot of problems. So I have two options. I can either wrap subsequent divs or components around each other, and that is just like kind of not great. Or I can write out each little piece and put all of the properties that I'm using in the, so I'm like calculating scale 1.23 and scale 0.5. So I'm kind of like manually picking the pieces of that interpolation instead of having the computer do it for me. So that's not great. What GreenSock allows you to do is separate out those values. So I can actually make many, many different tweens on a timeline. I can use each one of these separately. I also don't have to write transform, translate, x, all of that stuff. I'm writing x and y, which is not a huge deal, but it's kind of helpful. They will also assume that you want to hardware accelerate. If you're moving something, that you're just probably going to want to hardware accelerate, so that it'll automatically do that for you. The other nice thing is that they're not beholden to the spec. JavaScript is just more powerful than CSS is. So what they do here is they're using matrix transforms. They also do a lot of things where you can move attributes around as well. So that's really, really cool. To be totally clear, React Move, React Motion, React Tween, all of those can do this. But you'd have to write a matrix transform, and those are not the most intuitive thing to write. So that's how this is happening. That's like what the abstraction layer is obfuscating for you. So if you want to write matrix transforms with these, then you'll have really stable animations that can do things at different times. But the thing GreenSock allows me to do is animate the unanimatable, like SVG filters. It solves cross-browser inconsistencies. There's some really weird ones here, come on. IE's just like, come on. And that's Edge too. So these are all well supported in GreenSock, and you don't have to worry about them, which is just major for production sites. It also solves other transform origin issues. If you look at the pen on the right, that's actually how the spec thinks you want to interpret many, many stacked transforms. That's crazy. That's just crazy. The one on the left is GreenSock kind of figuring out that probably what you want to do is fix all of these. If you wanted to revert to the spec, you can do smooth origin false, so it's still available to you if you want that kind of behavior, but I've never wanted that kind of behavior. let's talk about morphing for a quick second. One really cool thing is the ability to manipulate SVG and morph from one set of path values to another, and they don't have to be equal amounts of path values. So there are other libraries that do something like this, but they have to be the same amount of path values. So that's cool, but what's more cool than that is that you can actually change the way that that goes. You can actually go through and find a different index, and you can see how changing the index for this morph completely changes the way that that motion manifests. So I can do things like make a candle with SVG, which is vector. Or I can make smoke. All right, sequences and chaining. These kind of things are... Sequences and chaining. Sequences and chaining are not the kind of thing you think about at first until you start to make something more complex, and then your code gets very, very easily spaghetti. If you're using delays for chaining, it's that thing we talked about earlier where you have to recalculate all the values. And I've never, ever made a longer, complex animation where I didn't adjust timing. That's just a very normal thing to do. Otherwise, you can use callbacks, and you can also enter callback hell, which I think we all kind of want to avoid. So one great thing about this timeline is it makes us not have to do that. It allows us to schedule all of these things. So we can stack tweens, we can change their placement in time, group them into scenes, add relative labels. So if we want, everything to fire off of one point in the timeline, we can add a label to that playhead and fire a bunch of things at once. We can animate the scenes. We can animate our animations. Like one line of code, I can change the whole timing of the whole thing. We can also reuse the scenes, play it backwards, and pause. That's really good for interaction, because if you ever made something like complicated that opens and you just want it to reverse on close, that's now one line of code instead of writing everything out. So here we're instantiating a timeline, we're adding a tween at the beginning, we're adding another tween immediately after. It'll just assume that you want it to follow that. And then we have, an incrementer here that's saying, like, okay, a little bit after that one. This is actually not showing all of the capabilities of timeline. That's just like the very, very tip of its capabilities. So some of us want to make things like this, right? Now we can make things like this. You can see how that circle is morphing into that, that square button. We now know how to do that. We can move things around. We can coordinate all these kinds of movements. And in figuring out how to do so, you can create small storyboards of your existing UI and try to find similar elements that can be simply altered with a transition instead of completely showing another view and breaking context. Okay, so we've dug into how awesome GreenSock is. Now, how do I pair that with React? Well, often I'll coordinate entrances and exits and give myself hooks with a library called ReactTransitionGroup Plus. ReactTransitionGroup Plus is not ReactTransitionGroup. They're similar, but it has some unique offerings. So here is a comparison of ReactTransitionGroup and ReactTransitionGroup Plus. We have something called in-out modes. It's pretty common in an accordion or a navigation or other pieces of our UI that we're not just coordinating entrances and exits, but we're coordinating something leaving and something else entering at the same time. So we can state without callbacks or chaining whether we want those two actions to happen simultaneously or if we'd like one to wait until the other one's done in order to enter. This is a really common use case. So we now no longer have to reinvent the wheel. So here's an example of a card flipping. It looks like one element, but it's actually two. One is leaving and the other one is entering. So we can schedule one to leave and the other one to wait until it's done and then enter. So without those in-out modes, you can see the picture snap forward instead of transition seamlessly. So now we know how to make some pretty cool stuff. This is made with React and GreenSock. React coordinates the state, and GreenSock choreographs all the intermediary values. So in this example, I'm using, in the state, I'm using this idea of screens. When we click on the button, we can advance the screen, looping back around to the first. And for each screen, we fire a function that handles our animation separately. Then we hang a timeline off of that function so that we can choreograph and finely tune the way that movement works. This event was simply our hook. So the other cool thing about GreenSock is that it allows us some methods to clear the properties that are set in line on the elements with clear props, so that we don't have to, if we need to re-trigger something, you saw how that looped all the way around, we can do so pretty easily. So if we revisit that first example that I promised you that I would revisit, you can now guess how we created this animation. We worked with GreenSock's timeline to draw those pieces of the SVG on, and then hooked into the transition components hooks with component will enter and component will leave to schedule the timeline calls. There's tons more stuff. There's draggable, motion along a path, custom easings, physics, and throw props. The sky's the limits here. So the main takeaway here is React is amazing at encapsulating the state that's changing. Animation ties these two states together, and with both of those, we can create beautiful fluid interfaces. I wrote a book. This is not that book. This is my friend trolling me. I don't have the man blob animal. That's not my last name. This is my book. It's available on O'Reilly now. It just came out. I'm also giving web animation workshops with Val Head. We have one coming to Paris in September. Thank you so much.